This is the demonstration video of the ANASTACIA use case BMS.3, a remote attack on a building energy microgrid. In this scenario, we will see an SQL injection towards a co-op server, where a compromised IoT device will insert SQL in the co-op payload. The detection will be made at the inbound network link of the server, so we'll be able to protect the server from any attack incoming not only from the IoT network. The reaction will be computed by the ANASTACIA platform and will be sent directly to the security orchestrator using an XML-based language called MSPL. The countermeasure will be effectively applied by the security orchestrator and the whole co-op protocol will be filtered. The deployment of this scenario is composed of 3 stages. The first is the attack triggering, where an emulated network containing the attacker will direct the traffic towards the victim, an SQL database, using ONOS and OSM in order to route the traffic. The second will be the monitoring and reaction, where MMT sniffer technologies will start to extract the information and feed it directly into the ANASTACIA chain in order to detect the attack and generate the appropriate countermeasures. Finally, the reaction deployment will be directed by the security orchestrator, which will deploy the computed countermeasures in order to filter the attack that is going from the attacker towards the victim. For the attack triggering phase, we will have an IoT emulated network that will contain the attacker and an IoT router. On the other side, we will have a victim that will contain an SQL database. All this communication between these two components will be made possible by ONOS, an SDN controller. On the attacker side, we will start the attack script, and on the victim side, we will start monitoring the incoming co-op traffic in order to see the packets coming from the attacker. ONOS will start to route all the packets from the attacker towards the victim in order to make the attack possible inside the emulated platform. In this screen, we can see the attacker and the MMT sniffer, as well as the mitigation action service and the victim. We will start the mitigation action service and we'll also start watching the traffic in the victim. So we will be able to see the packets going towards the victim. We'll also see that the BMS.3 attack, and in this case the SQL injection, has been triggered. The configuration we have so far is an attacker that is performing an SQL injection attack towards the victim. In this case, we will start the MMT probe that will start sniffing the IPv6 co-op traffic. The MMT probe will start to extract security information and will feed them directly into the whole ANASTACIA chain. The ANASTACIA platform will then detect the incident and generate the effective countermeasures in forms of an MSPL file that codifies the reactions to this ongoing attack. As said before, the MSPL file is an XML-based language, and we can see an example in this slide. This particular example codifies a filtering rule of a denial type from a source towards a destination on this particular destination port and this particular protocol, and in this case UDP. So reading this example is really easy from top to bottom. It is worth noticing that we are filtering the UDP protocol in the 5683 port. These are particular configurations for the co-op protocol, and therefore, with these configurations, we will be able to effectively filter all the co-op traffic from the attacker towards the victim. In our deployment, we see the different terminals here. We see that we will start the MMT probe that will start sniffing the traffic. And now we will connect the IoT border router in order to allow the communication between the attacker and the victim. Now, at this point, we will see that the attack will start and we can see some packets on the victim. After a few intents of the attacker, we can see that the attack has been detected and the MSPL file with the countermeasures has been generated. We can also see the detected attack into the XLCM interface, and we can exactly see that has been detected as an SQL injection attack from the source towards the destination. The third phase is the deployment of the reaction. At this point, we have an emulated IoT network where an insider attack is performing an SQL injection attack towards the victim on the other side. We will see that the computed countermeasures that will be received in an MSPL file from this mitigation action service, it will be read by the security orchestrator, and it will start ONOS and OSM configuration script in order to deploy a new virtual firewall that will be used to filter the co-op traffic. The security orchestrator will also deploy ONOS intent in order to redirect all the traffic towards this new virtual firewall that will perform all the filtering of the co-op traffic according to the MSPL file that was sent towards the security orchestrator. In our example, we see that the attack has been detected and the reaction has been sent to the security orchestrator. We see here that the MSPL was received by the security orchestrator and their status has been changed to in deployment. In particular, this countermeasure will create a new virtual machine that will contain a virtual firewall. And this new virtual machine will dynamically add it to the topology of the network. ONOS use intents in order to redirect all the traffic of the emulated network. In this case, this new VM will use different interfaces in order to filter the traffic. And in particular, we will use two IPv6 interfaces for the incoming and the outgoing traffic that will be used to effectively filter the co-op traffic of the ongoing attack. ONOS uses a total of 18 total intents, and 2 new ones have been appeared in order that will act as the filtering of the traffic. After a few seconds, we will see that the attack is effectively filtered. We can still see some UDP packets in the victim, and now we see that the co-op protocol is effectively filtered, even when we have some activities in the attacker in the upper window. The attacker sends the malicious packets, but they are not received by the victim.